Welcome back, everyone. Today we're going to be adding and subtracting radicals. Really not too bad of a concept, very similar to adding and subtracting variables. And we treat the radicals like variables, okay? So when we have radicals that we want to add or subtract, like we could see down here below, the rule of thumb is when adding or subtracting radicals, you need to make sure the radicands, that's the number inside the house, are the same. Okay, so it's like adding like terms. So in order to add or subtract variables, they have to be like. Both have to be x, both have to be y, both have to be z. Okay, so we take a look here. 5 root 3 plus 7 root 3. So the root 3's act like the variable. And we know that when we add or subtract variables, we add or subtract the coefficients, the numbers out front, and we keep the variable. So that's the same idea here. 5 root 3 plus 7 root 3, since the number inside the house is the same, we can add the numbers on the outside. We get 12, and we keep the number inside the house, 12 root 3. Okay, so keep in mind, like if we have a root 5 here, it's not written, but it's like having a 1 out front. So this is 10 root 5 minus 1 root 5 is 9 root 5. Okay, and then we get to number 3, and I'm going to add these radicals together, but what I notice is that the numbers inside the house are not the same. So I have root 3 plus 3 root 5, so I cannot put these together. Okay, so this would be our final answer. This is reduced, simplified, all that good stuff. Okay, so once people see that, we get to these type of problems, and they go, well, these can't be done. The numbers inside the house aren't the same. Okay, but if we take a look, the difference between these radicals, these radicands that are underneath the radicals, and if we take a look at these, 3 and 5, 3 and 5 are already reduced. 3 and 5 cannot be reduced any further. But if we take a look at these can be. Remember, and I'm not going to write this out for every one because these become pretty long, but we're going to think as 27 as 9 times 3. We're going to think of 75 as 25 times 3. And the reason why is we're putting these in simplified radical form before we determine whether or not these can be added or subtracted. So it might be a good idea at the top of your homework or sheet, you make a list of the perfect squares at the top like we've been doing, and then you can visually see the greatest one so that we can rewrite this. We're going to pull these out. So now this is going to become 21 root 3. This is going to become 20 root 3. And now you can see the number inside the house, the radicands are the same. So 21 root 3 plus 20 root 3 would be 41 root 3. Okay, so a couple more here because we do have one with a variable in it. We want to take a look at that. But this is one where, again, the numbers under the house are not the same. We're being asked to subtract these, okay, but they're not simplified. So in one step, we're going to simplify these. 50 is going to become 5 root 2. Negative 3 root 18 will become negative 9 root 2. And negative 2 root 12, I'm thinking 12 as 4 times 3 would be negative 4 root 3. Okay, so out of these, the only two we can really put together are the ones that are the same. So 5 root 2 minus 9 root 2 is negative 4 root 2. And now you're ready to roll. That's as far as you can go. Okay, so the numbers can get a little bit bigger. You just have to be careful here. You could think of 128 as 64 times 2. So we're going to pull out an 8. So we get 40 root 2. We think of this as 100 times 2, so we pull out a 10. We get 30 root 2, so our final answer there is 70 root 2. Okay, one more to go here. You guys are doing great. Not too bad of a lesson. Here, again, what's under the house has to be identical. It's got to be the same. These both have x cubes, but this is a 12, this is a 27. But what I do notice is that these are not simplified yet. So let's see what happens once they become simplified. All right, I'm going to show my work for this one. So I'm going to break down 12 to 4 times 3. This is an odd exponent, and what we learned in the last section is if you have an odd exponent, you'd break it down to the even number that comes before that, which is 2. 2 comes before 3, and we're going to rewrite this as x squared times x. And now I'm going to break this one down to 9 times 3 and x squared times x. Okay. So this is what we're looking at. We're going to circle our perfect squares. That's what we're going to pull out. So here I'm taking out a 2x. I already have a 4 here, so that's going to become 8x. Whatever's not circled is left in the house. Same idea here. I'm going to pull out a 3 and an x. There's already a 2 there, so this is going to become 6x. And whatever's not circled is left in the house. And now we can see, sorry about that, that the radicands are the same. So the rule is we're going to add everything out front. 8x plus 6x is 14x. And then we're going to keep what's inside the house. And we are done. Okay, so best of luck with the homework. I'll post all this once it's ready to roll. And I will see you guys tomorrow.